we're doing, so it's not just us sliding tiles around. Like, we want to document our algebra so we get more comfortable with that. So homework 29 to 34. Please make sure we're keeping up. Again, I did not collect this week because how awkward last week was. So next week on Tuesday, I will be collecting homework. But yeah, there wasn't much from last week, and by that I mean none. Right? Because we took the test Monday, Tuesday, and then we weren't at school Wednesday, Thursday, Friday. Like, yeah, there was none. I still have not gotten a chance to check your Chapter 5 homework because I had to work last night because one of my Rockwell people was sick. So you get the benefit of delay. If you still haven't turned it in, make it happen because that is on my list for tonight. I have to get these things done and get caught up because I might have to work again tomorrow night. Cheers to being an adult. So let's do algebra. Yeah? Yeah?
Sure. Absolutely. No, I don't want to.
I don't ever try to make those predictions because then it never happens.
Also, like, it's not like randomly that, and then it's going to drop like 20 degrees.
It doesn't matter. If the ground's already warmed up, you won't freeze that fast. All right. So Maria had her work from yesterday's class. You remember, this was a problem that we did yesterday together. So what I would like you to do real quick, write these steps down with a gap in the middle and leave space between each of the steps. So leave a gap in the middle, and you can do a dotted line if you want. But write down the 5x plus 2 plus negative 6. Leave a little gap. Write down the 5x plus negative 4. Leave a little gap. Why do I see pencils and doing nothing? How'd you write down your assignment? So, Garth is looking at Maria's work. And I'm just going to talk while you write. Garth's confused. Because he's like, all right, Mat A, Mat B, I know she's comparing. He's been in class and he's seen the work with the algebra tiles. But he just doesn't get what she's doing. So we need to help Garth figure this out. Casey, when I look at Mat A, or actually really when I look at any of this, going from step 1 to step 2, can you help explain to Garth like what Maria did?
She put the 2 and the negative 6 together, and she added 2 to negative 6 and got negative 4.
So these, let's go ahead and just draw like a bracket under these. And if you want to notate, this is putting together like terms. I need to adjust my smartboard. What about Mat B? Can you do that too, Casey? I didn't know if your answer would be super fast.
Did the exact same thing.
Thank you. Did the exact same thing, right? Just put together like terms. That's always what we want to do first. And when we did that on the mats with the physical tiles, we made zeros. Right? Because the positives and the negatives, if we have positives and negatives, zeros are going to happen. So over here, they must have made 2 zeros. And over here, they must have made 2 zeros because the opposite quantity of 2. So going from step 2 to step 3, Aiden, can you figure out how they did that? Or think back to what we did yesterday? This is just revisiting it.
Oh, from 2x plus negative 6 to negative 6.
Yeah, and same, like, because the left side is changing at the same time as the right side is changing.
So they probably did. Well, they always did combine like terms together. So the next step, but they didn't add the 2x. So they still have that to add.
So what they do? So they didn't add the 2. How did the 2x disappear?
They just combined like terms.
You can't just so that would be 7x if we just put them together.
Yeah.
We got to figure out what did Maria do. This is why Garth is confused, right? Like this is confusing. Kevin, you know how we got from step 2 to step 3?
I think he took away 2x from Mat B and then took away negative 2x from Mat A.
So in the gap that you left yourself, please write that he took away 2x over here, which means he has to take away 2x over here. Nice. Now my right side is just numbers, right? And now my left side, it looks like we're working towards making it the variable side. But right now it still has variables and numbers. So going from step 3 to step 4, Isaac, can you tell me what they did there? What do you think, dude? What kind of like disappeared, and how do you think that happened? Phone a friend. Anyone able to help him out? Brennan?
Took away the -4, so you can do it on the other side. That's how
How do you take away a -4?
minus -4.
What is minus -4? How can you?
Basically adding 4.
Yeah, we're and not basically, we are, right? It's the same thing. So please, in the gap that you left, show that he added 4 to both sides. Remember that blah property of equality? We have to do things on both sides. And then we got what we got, right? There's no other steps for us to figure out. Does the process that Maria took make sense? If not, what questions do we have? Because this is what we're doing today. We're going to write things out, show the work that we do on both sides to get to a simplified version.
Is she just allowed to take away 2x and add 4? She's just allowed to.
This is what I love about math. If you know the rules, and like, I don't like calling them rules, but if you know like what you're allowed to do, you can do anything you want, as long as you don't break the rules. So the blah property of equality said as long as we do the same thing on both sides, whatever you fill in for blah, you can do it. Multiply, divide, add, subtract, square root, which we don't even really know how to do yet. You can do any of that, as long as you do it equally on both sides. The blah property of equality. Yep. So that's why when she took away 2x, yeah, she can just do that as long as she does it on both sides. Other questions? That was a good one. They're all good ones. But what? Every question is a good question. There's only bad answers. There are no bad questions. Going once. My smartboard's broken. We'll get rid of that because that's pointless. Going twice. All right, moving on. So now we're going to compare 2 plus 2x plus -3 compared to 2x plus -4 plus 1. So go ahead and leave a gap in the middle. I'm going to switch my screens. So I'm going to let you write these down real fast, and then I'll switch my screens. So leave a gap where the and is, like split them up. Sorry, I did not get the +1 there. Sorry, now I didn't get the 2. I'm being really bad at highlighting today. Then process through with your partners or alone if you want. Figure out how do I get this as simplified as possible. I'll use graph paper. So I want to encourage you guys as we get into algebra, please use the lines on your paper for like separation and things like that. So like don't just write diagonally or like super huge or whatever. Like, use those lines so we can separate. Here's what we have. Here's what we did. Here's what we have. Here's what we did. So we start with what we have. I don't like doing that in red. In my brain, change is red. Like something that like, oh my gosh, something's happening. So whenever I write changes, I try to change my ink up here to red. But that's just in my brain, right? Jalen, was it you that was talking to me about seeing like colors and letters having like emotion? Oh, okay. Well, she was.
Yeah, she did. She said that to me too.
Yeah, we were having this interesting discussion. I said, yeah, I feel like numbers have personality. So like, take a couple minutes, try to work this process. Then I'm going to random card and ask step by step. If you're confused, stick up a hand so I can help you, or ask your partner first, really. Again, if you want algebra tiles to do this, grab them. If you want a Chromebook to do this, grab it. It's middle school.
So wait, we're doing A and B.
So you're 624. I just want you to process through like we did yesterday, combine the like terms. You can do whatever you want on both sides. And we're just trying to compare mat A to mat B. So maybe we need to do another one of these together. So Skylar's not here.
She went to the
Sports thing. Natalie, what's the first thing you're going to do? Now, before we start getting deep into algebra, realize there are often multiple correct ways to go through this. So if Natalie says something different and you do not immediately erase or you're probably fine. Natalie just maybe took a different route than you, or you took the same route. So what did you do first?
Well, I added the ones.
Oh, the one tiles, the like terms. So in my brain, I put those together like that, and I will then say we have 2x. What do we get when we put those together? -1. And over here, they're already beside each other. We get 2x and sure, yeah, go ahead.
And then I took away both two x's.
I need to restart my smart ink. So Natalie took away both 2 x's, so I write that in red because it's a change that we're doing to both sides. Now, when we get deeper into this, what's going to happen is you'll have some sort of symbol between here, and then where you draw, like where you write out your change, you don't put the equal sign or the greater than. It's just a step in between your equal steps. So actually, if I really analyze this, I can see that the left side is going to be bigger than the right side if I just compare the negative values. So how that will look when we get further into algebra is this would be there, and then it is not here, and then I write what I have. So I have -1 now, -3, and we're done. Okay, now that worked out, again, nice and easy. Like some on your homework that it has the same variable value, and the variables can just kind of be gotten rid of. But that doesn't always happen, right? So when we get rid of the variables, it's really easy to see which one's bigger. But what did we talk about yesterday? That if there's variables left over, make things complicated. And this is a really complicated idea. So guys, hear me when I say I know this is difficult. I'm trying to go slow as we get into this. What's the problem if we have x's left over? Like if I had x plus 7 compared to 10. Layla? We don't know what x is.
And we can't subtract x because it's x.
And we wouldn't, well, we could, but it just would push it to the other side, essentially. We'd end up with a negative x over, remember, you can do whatever you want as long as you do it to both sides. You could, but there'd be no purpose. Do we know that x is positive?
No.
No. This is something I want to reiterate to you guys. The positive value of x, like just saying x, not negative x, that's a number we don't know, and it could be any number.
So it could be negative.
It could be negative. Then the negative x would be positive. So we might want to write this out to clarify for us. The smartboard is really having issues today. I think I got to shut this down and restart it. Let's go ahead and put another if statement. So x could be anything, right? We don't know until we know. If x comes out to be a negative, then, and this is a big way that mathematicians or any math students talk about certain things, if-then statements. If this is true, then this is true. If this is not true, then this is not true. So if I get a pizza, then I'm going to eat the pizza. But math statements. Then the opposite of x is positive.
You've never done that?
What? Get a pizza and not eat it? I would not have that self-control. So guys, this is where everyone gets like upset, confused, like all because we say x is a quote unquote positive x doesn't mean the number it represents is. Okay? So if I tell you, I went to the grocery store with $20. My smartboard's just not working today. If I tell you I went to the grocery store with $20 and then I purchased a pizza for X dollars, like, and in math says add, right? And then I made a purchase and I left the store with $8. What's X? It's negative 12. Because instead of subtracting, I said a statement that needed addition, and then I got a pizza, right? But that pizza gave me a debt value, so X becomes negative 12. That's a situation where X could be a negative. Okay? Back to the lesson. All right.
How does 20 plus 12 equal? Oh,
Negative 12. I have $8 left.
That makes sense.
So what you want to do now is write down expressions, and I guess I'll move it down here for a minute. Write down expressions to represent what Maria and Garth start with. So here, let me give you the situation, and then you can dive in. Maria has mat A, and Garth has mat B. They describe like handfuls of tiles. Maria says, my mat's bigger. And Garth is, are we sure? But eventually, because of what we just talked about, right? X, we don't know what it is. Could be positive, could be negative. Garth says chivalry is not dead. Chivalry is from the time of knights and princesses and stuff. He says, fine, Maria, you can have it. You can say that mat A is bigger. I'm going to give you guys a few minutes to work through this. That's why I'm trying to set up A, B, and C and everything. So Garth says, all right, Maria, I will let you say that mat A is bigger, but you have to tell me how. So your task is, once you simplify this out, determine values of X that make Maria's mat bigger. So we're essentially saying, what values of X make Maria's quantity over here bigger than Garth's?
Does Maria's X have to be the same as Garth's?
Yes, the X's are the same as each other. But I think we can get rid of Garth's X. I think. We can make it so Garth doesn't even have one. So first, write out what they've got, then process through to simplify. You can go ahead and put that greater than symbol in there. Yeah, I like it. Some of you guys are drawing that dotted line down the middle to keep the sides separate. Some of you are drawing pictures to help you out. I am very algebra brained, not geometry brained. I don't normally draw the pictures. My sister stole the artistic ability.
You have a sister?
Uh-huh. If you ask me later, I will show you her Instagram where she sells art and stuff.
She sells art?
She's a painter. She lives down in South Carolina. I love vacationing down there.
I'm going there at the end of April.
I'm going there in summer, Christmas, and every year of my life.
Maybe going there for summer.
Well, not very.
I go any chance we get.
Every year till I'm 8.
So we start trying to simplify. You guys can keep doing your work at your desks if you want. Yvonne, what do I do first, or what do you do first? Did I not give enough time? No.
I think I
You can do, well, I called on you when you were out of the room, so let's come back to you.
Yeah. You add 3 and -1.
Yeah, we have like terms, right? So if we're going to talk mathy, we combine like terms. So I draw that by doing like a little bracket and just saying these guys go together. What do I get then?
2.
2. And x plus 5.
And then
Yeah. Yeah, mathy. If we're talking like a math way. It's not gross. It's beautiful.
subtract x, and then bada bing, bada bing.
Ooh, I only have 1 x over here on Garth's side.
Exactly.
Jalen said we can get rid of Garth's x. You don't deserve an x anyways.
Yeah, you don't. So x plus 2.
So we then have x plus 2. And 5, right? No, wait, we said that Maria's mat's bigger, so I could have had these in here the whole time. So I'm going to pause here. You with your group need to determine, because then I'm going to random card, values of x that makes this true. Take like 30 seconds, a minute, whatever. Good conversations happening.
Hi.
Ooh, Riley thinks pi could be an x value.
I came up with the idea.
I mean, yeah, I guess, sure. I don't know that I've often been described as mean. I was normally a pushover. I was pretty timid, actually, growing up. Brendan, give me value of x that would work. 6? Sure. 6 plus 2, 8, bigger than 5. Greta, give me value of x that would work. Oh, she went there. Say that louder. Anything above 3, because I think with what I know of Greta, she doesn't like the nonsense, and she's like, let's just get to the point. X, can X be like 8,000? What about like 40 million?
Yeah.
So if we were to try to graph this, actually, I'm getting ahead of myself. Is there a way that we can use those algebra rules and get to what Greta just said? What else could I do in my situation to get the statement Greta just told me? Sophia? Yeah, we can add -2 or we can subtract 2. And my equation, my inequality actually becomes this. And we know straightforward x is anything above 3. So do we know what x is? Not really. We know a range for what x could be. So when we go to present our solution back to Marie and Garth, we're going to present them not only that inequality, but do me a favor and draw a number line real quick. Now, I told you, I will swear on the math book or whatever you want, my genuine job has morphed over the past 7 years into, I'm not joking, trying to make your life as easy as possible. And realize how hard it is to be middle schooler. So I'm going to teach you the easiest way to do this that's way simplified from what the book does. What number do we care about here? 3. That's the only number we have to put on here. Trust me, I'm trying to make your life easy. Then we are going to shade every possible value for x. Riley?
It's gonna be like, you can have a dot where the 3 is, and then
Can I have a dot?
No, but like you can have one, and then you can have a line going to the side.
You just said I don't, but I can. I think
You
you're
don't have a
contradicting me.
dot there.
I don't want to put a dot there, and I know I'm being annoying with
Okay, well, you
this.
can have an arrow.
Adrian?
You put a dot just after 3 and then an arrow.
Yeah, but how do I put a dot at like 3.00000000000000001? How do I get that close?
You don't.
Computer girl.
You don't.
Anybody done this before? I don't expect that you have. I'm just curious if
You
anyone
just
knows
put
it.
it next to the 3.
So, everything you guys have said is right. I'm just pushing you because you're not being specific enough. We want to shade, hold on, don't do this yet. We want to shade everything out here, and you guys said we put an arrow to tell it to keep going. Here's how we say 3 is not allowed. Open circle.
Yeah.
It's not a dot,
But
though.
that's not okay because the dot is like
A dot is a dot.
The dot is for like when it's like.
So, do me a favor. In your notes, I don't often ask you to write vocab. This is what we call, and we're going to start using this a lot in your homework, is going to ask about it, a boundary point. Kind of like if your parents say you can't ride your bike past hard road or whatever. That boundary point tells us the number we care about and which direction we go, because number lines only operate like negative to positive, negatives on the left, positives on the right. Like, we don't ever use a different number line. Now we can flip this vertical. And we can show this vertical, but we often don't. Just as horizontal number lines often fit on our paper better. But this is how we show an entire solution process all the way down to presenting the graph of it. Are there any questions on this? Trust me, I know I'm going
No.
So when I say do it on your own, you can do it on your own?
Yes.
So, do it on your own. If you don't have a textbook, I will scroll down the book. Delete. Here you go. 2x plus 5 is less than 3.
Ooh, okay.
Sorry, I'll move it onto this screen. 2x plus 5 is less than 3 is where you're starting. You need to end up graphing for me all possible values for x. I shouldn't say graphing for me, graphing for you. You're the one who cares about this. These are awkwardly close. It makes my lap tight. Good. I like when you popped over that part. So yeah, we got to start by writing this down. The first thing I should see on everybody's paper is 2x plus 5 is less than 3. Don't start doing work until you have what we have. 2x plus 5 is less than 3. 2x plus 5 is less. Now, okay, so really quick, because I know you're working on that problem. Notice CPM shows you the whole number line numbered with every single digit. Here's me saying, I don't care for you to do that. You can, you don't have to. The only number we cared about here was 3, so we would have put our open point here and shaded to the right. It doesn't matter that we showed all those other numbers. Secret, no one cares. So, just make your life easy. Like, you can do it, but it doesn't help anything. It doesn't tell you anything else. It's just not important. You know what I mean? Not like no one cares about you. I definitely care about you. I just don't care to see every digit on the number line. Yes, I'm crazy, Natalie. I know. Just do what I'm
So
asking
you're
for
trying to
you.
figure out x.
You're trying to figure out what x's boundary point is, if we're being more specific. Cannot be equal, has to be less than. I agree with that statement.
Really break it down. Going on the last page, you said break it down.
Try to get the x on its lonesome. Sorry, I'm doing a good job getting through random parts. I'm going to keep going. We just talked, so unless you want to, do you want to go again? Okay. Labiba, what are you going to do first here? So I can't see your mouth. So what are you going to do first here? If you don't know, I can always pass it. I don't want to know what x is. I want to know how we get there. Right.
Yay, okay. So, you don't have like, or you can, I guess, if you want to. But X would be
Yeah.
negative.
I don't want to know what X is.
Okay.
I want to know what we do. Even?
You subtract 3.
We can, but that leaves nothing on the right side. We don't really like when sides have nothing. We could. I agree, we could. I just don't know if it's the best route. Adrian, what are you thinking?
Make a number line.
Oh, okay, with that eventually. Eva? Absolutely. So here, guys, do me a favor. Eyes up here for a moment. Here's the thought process you should be going through. Which side should I keep variables on or put variables onto? Which side should I have my numbers be on or put those 1 tiles onto? We have, can't use that. We have a variable value, a constant value, which is what we call just numbers. Constants are numbers. And then constant over here. This side is mixed, and this side isn't. So just make it your constant side. So get rid of this 5, and we do the same thing on both sides. If you didn't do that, please just humor me and do it, because trust me, this is the easy way to go. Now, often, people will try to tell me, to get x alone, I need to divide by 2. And I agree. But I want to show you why we don't do that until the end. If instead of subtracting 5 here, I said let's divide by 2, because we can, right? I'm allowed to do anything I want as long as I do it on both sides. Here's where the problem comes in. I don't just divide this by 2. I'm dividing the left side by 2. So this would also divide by 2, and this would also divide by 2. So now I've got a partial value here, like 2.5. Got a partial value here, 1.5, and this gets gross. So instead of going the hard route that I'm trying to make your life easy, we first get rid of constants and push those all together. Once we have separate sides for variables and constants, which we have now, we have 2x, it's just a variable, and -2. Right now I say this is just a variable because remember, think about what it looks like. X, like 2x tiles, right? There's no 1 tiles over there. Now we can. Okay, why's your hand up? Were you going to tell me the answer or what? Or was your hand not up? Okay, so what's x then?
Anything less than -1.5.
Ooh, careful. If I divide by 2 here, if this subtraction was right, what's -2 divided by 2? I think it's just -1. I don't think it's 1.5. I think x is less than -1, right? Yeah? Check your work. See, I might have made a mistake, but check your work. Am I, like, seriously, am I right up here or not?
I got that answer right. Wait.
Brendan?
2x would have to be -3, so you have to half it, and then you would get -1.5.
I have to half what? What do you mean?
So in order for 2x plus 5 to be less than 3,
Yeah.
2x would have to be anything lower than -3.
So what's scaring me here is how your thought process is going. Like what you're saying can work out. We can like make it that way. But so understand your point works, but it's not as close as I can get. The closest I can get from making this possible is -1. -1.5 would work. That's a value that x could be. But when we go through the algebraic process, right, this like branch of mathematics that has these rules, we want to try to put my constant values with each other. Then we do that division that you're talking about. So really, when we talk about 2x, 2x has to be less than -2. That's how 2x compares to the constant. So when we go to isolate x and we do the division, x is less than negative 1. Okay, let's try another one of these. And see. Oh, and then we can graph it. Right, so let's do that number line real quick. X is less than. So what's the number I put on here?
1, negative 1.
Negative 1. Is the circle filled in or open?
Fill in. No,
Okay.
it's open.
Ooh.
No,
Keep
wait.
your eyes real quick. If this had the or equal to, if this had the or, then we'd fill in the
Because
circle.
My teacher told me that like it has more ink.
Yep, absolutely. More ink needs more ink. But here we don't, so ignore that red line that I just put there, and we shade to the less than, and we put the arrow on the end. Try Jerry and Ken's problem. 6 is greater than 2x plus 2. Please follow the process that I laid out for you. Put the constants on a side together using the mathematical processes. I'm doing this one now. Sorry, the zoom kind of broke it up. I'll zoom out because of that. 6 is greater than 2x plus 2.
I keep combining
Kind of. We can't combine like terms until we say we're going to do something.
Oh.
So you're saying like put the 6 and the 2 together? Nope.
What?
They're on different sides. They're like in different rooms. They're in different places. We cannot just put the 6 with the negative 2. We kind of can, but we're not using that 2. Yeah, kind of. I mean, maybe. They can like put the hand up against the glass. Hello from the other side. What can I do? Anyone want to help me? I'll stray from random cards. Greta? Yeah, either add in a negative 2 or subtract 2. Either way does the same thing. So if we subtract 2, we then get 2x over there, 4 over here. Now what do we do to get just a single x? Isaac? Divide by 2 on both sides, because we should be writing these steps that are happening between here. And, no wait, this one's kind of turned around. How do I read my solution down there? If I go left to right, how do I read that? Kevin? 2 is greater than x. So if I want to say the x first, if I go to turn this thing around, we could say x is, yeah, turn the whole thing around. X is less than 2. Number line, we just care about the 2. Circle, then we decide open or shaded. It's open, right? Because it cannot be 2. It has to be less than 2. So we shade left or right.
That way.
Preguntas. Adrian? Or is that not a hand?
No.
Okay. Preguntas means questions in Spanish. I've said this many times. It's a fun word. I just like it. Also, if you are ever in a Spanish-speaking country, one of the most important phrases to know is "Donde está el baño?"
What's that?
Where is the bathroom?
What?
Where is the bathroom? Donde está el baño? Where is the bathroom? All right. Any questions left from today? So the last thing they wanted you to do, but I want to make your life easy, so I'm not going to make you, as long as you can think through it. This answer here can either be written as 2 is greater than x, or x is less than 2. We could write it either way. It graphs the absolute same way. Remaining questions. If you have a Chromebook, you want to get rid of that, or if it's your own computer, you probably want to start shutting it down. We have like a minute or 2, maybe. If I was you, I'd go ahead and head a paper for homework if you haven't, just so it's done in your binder. If you get confused about any of the vocab in your homework, please reference this. I feel like a lot of you guys do your homework in Homework Help, which does not show you all the textbook stuff. So I would encourage you, have the ebook open, even if you're using the Homework Help page. These words get used in your assignments now. So we talked about constant just means a number. Here's one that you don't know, because I have a minute left, so while you're packing up, I've maybe used this a couple times, but the coefficient is a fancy word for the number that's multiplying by the variable. So here the coefficient's 2. Here, the coefficient's 7. Here, the coefficient is negative 15, actually. Because it's whatever number is being multiplied by a variable term. And that is all the time we probably have. Have a wonderful day, guys.